Hey guys, Jack here. Help. Uh, this math problem. It's something I just discovered. Um, it wasn't like something I found on the internet. This is like an original math problem. Um, so I'm gonna write it out to you, okay? Prepare yourself. It's a bit of a doozy, okay? It might take a while to figure out, okay? I've been trying for a couple hours now, and I have not been able to get anywhere on solving this, okay? So, let me straighten my paper. Straighten my paper. There we go. You ready? Okay, I'm gonna start writing it out. So we have 8 integers, okay? And your job is to find the so it's your job on the problem is to find these 16 what these 16 numbers are. Or yeah. No. No, it's hard. Sorry. No, my bad. That's completely wrong. It's harder than that. Um okay, so how do I even know how to write this down? Yeah. Okay. Okay, here we go. Um, okay, so quick disclaimer: this is not multiplication as well. Um, these are just each their own thing. So this isn't like a times z. This is just a z as one thing. Okay. Let me start writing this out. I'm actually gonna actually, you know what? I think it's better if I pause this and then bring you back when it's here. Okay. Okay, here's the first line. Doesn't look too complicated yet, right? Oh, it's just a bunch of adding gives 12. Um, Here's the next couple of lines. I'm sure you can't see most of that right now, and but don't worry, I will zoom in after. But hang on, there's a bit more to write yet. Okay, there we go. Now we are about halfway done. Okay, and finally the entire thing is written out. So as you can see, this is a relatively simple problem. You just have to put it into thinkable terms. You just combine AZ and AY and AX and AW and AV and AU and AT and AS into 12 and then BZ and then BY and BA. You get the point. So let me just readjust this so you can see better. Yeah, so it's basically it's just really simple. It's just really simple addition. So yeah, you just gotta do that. And then there's that. Okay, everyone see that? So, um, if anyone can solve this, um, I guess there's technically a couple of limitations. Um, so to be clear, the variable sets are each their own thing. It's not a times v. It's AV. It's its own variable. So AV is just one. AV is a number, and BV is a number, and DX is a number. So they're all just numbers. Um, I think there was something else. Maybe that's actually it. They're all just numbers, and I think that's it, unless I'm forgetting something. Right, I remember now. So the two letters together are all just in place of one number. So it's not like a number times a number; it's all just one number, and they all have to be integers. So they all have to be. All these every number has to be an integer, and each integer. So they all have to be integers. They can be positive or negative, but they all have to be integers, and they're each just one number. I think that's the only limitations. So you can't have like 1.5 anywhere. You can't have 2.0007. And again, it's not a times x. It's just ax is one. Ax stands for one thing. There were just too many combinations though to have been able to write A, B, C, D, E, F, G, because you run out after 26, and there is some 48 pairs here. So yeah, good luck. I'd probably say this is the hardest thing that I would ever have to do. I am going to try, not on camera. I have been trying for a couple hours. This is it's somewhat important. If it's not solved today, it's not going to be as important. I can work around it, but it would be nice to know, A, if it's possible, and B, what the hell is the solution? Everyone got that? Great. Hope you guys enjoyed. Remember, if you enjoy content, be free to like and subscribe. Yeah, I don't know, feel free to join my Discord if you want to have if you want to try and like have a discussion with other people maybe trying to solve it. If anyone's trying to solve this. I wanted to give a quick clarification on the rules because I realized I realized I didn't make it very clear. The goal is to figure out what the 48 variables are. There's 48 of them. The goal is to figure out what the 48 variables are. And the variables can be any positive or negative integer. They can't be 0 as well. Something else I forgot to say. So just like the ones that equal 0, everything can't just be 0. So they all have to be positive or negative integers. They all have to be whole numbers excluding 0. And your goal is to find the 48 of them. So that's the clarified rules.